Bienvenidos, Ushamdi, and welcome to this director's cut from HUT8 on MPLS Layer 3 VPNs, where we're going to be taking a look at doing some BGP route reflection. And in part one, we're going to be taking a look at adding a single BGP route reflector, and then in part two, we're going to add in a second BGP route reflector, and we're going to go ahead and set it up in peer between the route reflectors. We're going to talk about the cluster IDs, how to set the cluster IDs, what happens or why you would want to have the same cluster IDs on your BGP route reflectors, or some use cases where you would use different cluster IDs on your BGP route reflectors. And so just to let you know, I also wanted to say thank you so very, very much. I just recently surpassed 10,000 subscribers on my YouTube channel. And one of those subscribers, when I had done the director's cut originally, had asked me to put some route reflectors in there because that's typically a more realistic scenario. So I've gone ahead, we're going to do some route reflection here, but again, I really want to say thank you. It's greatly appreciated. I never thought I'd have more than about 100 subscribers, so it's certainly very kind of you, and hopefully these videos and tutorials have been worth your time. So let me go ahead and refresh your memory on where we left off. And a quick note, the configuration, when I am done with this scenario, I'm going to put a link in the description of the video to Dropbox where you can download the configurations for every single device, the final configurations as we're done here. So what I'm going to do first is I'm going to go ahead and we're going to make router 9 our route reflector. Now, if you remember from the previous videos in the MPLS L3 VPN series, I did OSPF as the PE to CE, I did EIGRP, I did eBGP, and so that's the config I have here with the addition of these two routers. So we've got router 9 and router 8. Now these are going to be our route reflectors, and here's the key with the route reflector. They are not going to be in the data plane. In other words, they're not going to be forwarding our MPLS traffic. So we don't want these to be involved in the forwarding of traffic. And we also do not want OSPF to select these, router 8 and router 9, as preferred routers for the forwarding of traffic, because that could cause problems as well. So we're going to do a number of things. We're going to talk about some Cisco best practices, and I'm here to tell you we are going to disable Ceph on both router 8 and router 9. Again, they are route reflectors. They're not going to be forwarding traffic. So some of the things I'm going to do might be a little unconventional. However, they are Cisco best practices when dealing with route reflectors. So let's go ahead and pull up router 9. And actually first, let's take a look at router 1 and let's make sure that we have reachability, and we should. So again, this is router 1 where we left off last time. So if I was to ping the 6666, which is router 6 for customer A on the other side of our cloud, and source that from either my loopback 0 or the loopback 192, which we created, we should see that we've got full reachability across the cloud. And so how did we leave things? Well, on router 3, this was our PE router, right, or PE1. So let's go from user exec to privilege exec. I'm going to say show run, and we're going to pipe it to section router BGP. And so here's the BGP configuration that we have currently. Remember, it was only the PE routers that were peering with each other in order to provide those VPN v4 updates. Remember, it's the route distinguisher and, in our case, the IPv4 address that makes up the VPN v4 prefix. So the route distinguisher being the, I can't remember what we use, 65,001. If I say show VRF, we should see it in there. Yeah, so I think, I'm sorry, we used 1:1. So that's what we're using as our route distinguisher. Remember, the route distinguisher is not, I repeat, it is not a BGP extended community. I'm sorry, yeah, it's not a BGP extended community, right? It is simply a value that's used to make the IPv4 address unique so that we could have overlapping IP address space. So that's our config on router 3. Let's take a look at router 5 here real quick, which should look very similar to 3. And remember, when we're talking about creating these iBGP peerings, do show run section router BGP, when we're talking about creating these iBGP peerings, we need to have a full mesh with BGP when it comes to iBGP peerings. So obviously the viewer that had asked me, well, hey, can you do something with route reflection because that might be a little more realistic? And so what the route reflector allows us to do is it allows us to avoid having to create a full mesh. And you're very familiar, I'm sure, if you're not, with the equation for that full mesh, which is n times n-1 divided by 2. And so in our topology, not really a concern, right? But when you get into larger enterprise networks, that full mesh requirement might become something that you're concerned with. And so route reflection and route reflectors in general is a way that we can circumvent having to create a full mesh of iBGP peerings. All right, so let's go ahead. We're going to actually do a transition here. So it's kind of a fortuitous, I don't want to say fortuitous failure, but fortuitous that we're going to be adding some route reflectors in while we already have this peering stood up between router 3 and router 5. In fact, I'm going to go ahead and we're even going to do a peer group on router 9 for the route reflector clients. And then in part 2, when we bring router 8 on board, we'll just go ahead and we'll create the BGP peering in the VPN v4 address family for the 2 route reflectors. And we'll go ahead and do that without a peer group. We could use a peer group. We don't have to. So we'll do it both ways. That way you can see what it looks like. So let's jump on to router number 9 at this point at the top of our configuration. So here's router number 9. And I'll let you know that I've already done the OSPF config, and I'll show it to you here for full disclosure, section router OSPF, so that you can see that we've got kind of a basic config in here. But I'm going to talk about one significant change that we're going to want to do because this is a route reflector, and I kind of already mentioned it, that we want to take OSPF, we want to take OSPF out of the equation. In other words, we take router 9 out of the OSPF equation, is probably better said, because we don't want, for whatever reason, any traffic to flow through our route reflectors, whether it be the data plane for the MPLS L3 VPN traffic or just the OSPF traffic. So how can I do that? Well, I'm going to say router OSPF 1, and we're going to go ahead and set the max metric on the router LSA, and it's going to make this router the least preferred out of the routers that we've got here. So again, this is one way or one step I can take in order to ensure that OSPF is not going to prefer router 9. Because remember, all we want router 9 doing is reflecting BGP routes. The next thing I'm going to do is I'm going to say no IPsef. Right? Now, typically you hear, hey, whatever you do, don't turn Ceph off. And in most use cases, that's correct. But when we're talking about route reflectors, and as I just said, we don't want them in the data plane. They should not be in the data plane. They should have one purpose and one purpose only. That's reflecting routes. We want to save resources on the router, so we're going to go ahead and shut down Ceph. So the next thing I'm going to do is let's take a look at the do show run. There should be no router BGP. Should be no BGP configuration section here, and there's not. So let's say router BGP 1, and let's start getting our route reflector set up. So the first thing I'm going to do is I'm going to say BGP router ID, and we're going to set that to the all 9s. And I'm not going to set the cluster ID. I'll wait for that to happen when we do the second route reflector. So let's go ahead and say no BGP default IPv4 unicast, right? Remember, this is actually the use case we're talking about for that command, is in a service provider environment, because the peerings here are going to be VPN v4. And I don't want, for whatever reason, one of these other BGP peers to establish by accident a peering with router 9. So now that I've got that set up, let me go ahead. Oops, sorry. We'll go ahead and do the peer group setup. So route reflector client, I'll just say RRC and peer group. So that's how I define the peer group I'm going to be using. Now I'm going to say neighbor RRC, or actually, I'm sorry, we're going to say RRC, and I was getting ready to go into the IPs there. So we'll put the remote AS in here, and I'm trying to remember how I did this before. And then we're going to say update source loopback 0, right? And remember, all of these settings here are going to apply to any neighbor statement that I associate with peer group RRC. So I think that's it. We've got the remote AS1, the update source loopback 0. So now I can go ahead and drop this in and say 3333. Now, if I did a question mark here, you'll see that when we get down to the bottom, I've got peer group as an option. And so that is how I'm going to associate router 3's neighbor statement with the settings that I just created in RRC. And again, I can pull this back up and quickly change this to 5555, right? So we've got the peer group set up for both router 3 and router 5. Now remember, this is a route reflector, but it is specifically, this isn't an MPLS context, L3 VPN, and it would be the same if we're talking about L2 VPN as well. But in the MPLS context, I'm talking about the VPN v4 address family, right? That's what we're going to need here. So I don't want to say address family IPv4 because this is not a conventional or a classic IPv4 peering for the address family. It's going to be the address family for VPN v4. So I say address family VPN v4. Now I'm going to say neighbor. I've got to put the peer group in here, and we're going to say send community extended. Now, I don't actually have to type that, in fact. So if I were to pull that back, I could say neighbor RRC and then route reflector client. Now, this is different than how you would normally do this, because remember, we're using a peer group here. If it wasn't a peer group, I would say neighbor the IP address like I would on the activate statement. I would say neighbor IP address and then route reflector client. But watch what happens here. Because of the peer group, you're going to see there is no option. When I say neighbor IP, there's no option for a route reflector or for a route reflector client. So that's why we define that with the previous statement. So do show run section router BGP. Whoops, sorry. Let that bomb out, router BGP. And we take a look at this. And so this is what we've got so far. So now I can activate the client. And actually, before I do that, quick note, it's nice to see, again, it puts that send community extended. Now, your mileage may vary based on the iOS release you're using. This is 15.6 code, and you should be 15.6 or 15.7 if you've got recent gear. On older gear, you may have to type in that send community extended. So, but it auto-magically does it for me here. So now I can come back and say neighbor 3333 and activate. Oops, I always forget the T. Activate. And then I can say neighbor 5555. And activate. Now you'll notice the peerings aren't up, and that's okay because we have a functional environment right now, and I haven't done the configuration on the route reflector clients. So we should have everything in check here. Let me go ahead and say write mem, and then let's take one last look at our BGP config here. So show run section router BGP. And that's what we've got. So we've got two route reflector clients that have both been associated with that peer group that we created. So that way we only have to type in the remote AS one time. We only have to type in the update source one time. And so now let's go ahead and cruise over to router number 3. And we're going to add in the peering for router 9. And then we're going to remove the peering for router 5. And actually, let's see if we have any disruption with our traffic here. So I'm going to say ping 6666, source it from loopback 0, and we're going to repeat it a whole bunch of times. And so that should hold us over here while I'm typing these commands in. So we're going to go router BGP 1, and we're going to go ahead and say, and again, no peer group here. So we'll just say, what are we going to do here? Do show run section router BGP. Let me see what I've got in here right now. We should have the customer VRF, IPv4 statements, we do, and we've got the VPN v4 for router 5. So I just want to take a quick look here to see what we've got. So let's go ahead and say neighbor 9999, and the remote AS is going to be our AS. And I don't use a route reflector client statement here because this is the client, right? It's on the route reflector itself in the cluster that we put that route reflector client statement on. So then here we're going to say neighbor 9999, update source loopback 0. Now you'll notice the peering's still not coming up because we've got that no BGP default IPv4 unicast command there. So what am I going to do now? Well, now I've got to go into the address family VPN v4 unicast, and we're going to put in the neighbor statement for 9999, and I'm going to say I keep forgetting the T. We're going to say activate. Now, this should bring up the peering between 3 and 9. As you can see, it does. Let's take a look here at router 1. All right, traffic is unimpeded at this time. Whoops, sorry, I want to be on router number 3. So traffic is still flowing. We've got the connection up. Now, let's come back over here to router 9, and let's say show BGP VPN v4 unicast all. And let's see what we've got. Well, take a look at that. We have already the NLRI that we're having advertised from client or customer A, which are these two networks here, the 1111 for router 1. So we're looking good there. So let's come over to router 5 and let's do the same thing that we just did on router 3. And I'm not going to remove the statements until we've got the router 3, the two PE routers configured and up and running, and we see the NLRI for the VPN v4 address family on our route reflector. So do show run section router BGP, and let's take a look here at what we've got so far. And yeah, it looks exactly like router 3 did. So let's go ahead and say router BGP1. And I'm going to go ahead and put my neighbor statement in here for the 9999, and the remote AS is going to be 1, and then I'm going to say update source loopback 0. Right, and remember that command, that update source loopback 0 is only required on one side, but again, it's good practice to get it on both sides. So address family VPN v4, and we're going to say neighbor 9999, whoops, and activate. Now, I'm sorry. Excuse me. This should bring our peering up here in a couple of seconds. Let me go ahead and say in, and there we go. We can see that it's up. So we'll do a quick write mem here and save that. Let's come back over to router 9. And now router 9 should see more than just the 1111 and the 192.168.99. Now I see the NLRI that we know is coming in from customer A, router 6, right? All right, so the peerings are up. Let's take a look at the traffic. Any interruption? So everything looks good so far, right? So no interruption so far. So now let's come back to router 3, and we're going to exit out of here. I'm going to say no neighbor, and what was that? Interrupt. Okay, yeah, so that's fine. So I'm going to say no neighbor. This is router 3, so we'll say 5555 remote AS 1. So we're going to get rid of that. Let's see any impact to traffic here. Traffic is continuing to flow. So what does our statement look like now? Let's see our show run section router BGP. So the BGP configuration section is going to look like this. We've gotten rid of the peering with router 5, but that's okay. We've got the route reflector, router 9 in here. So everything looks good. So let's go ahead and say write mem, and we'll come over here to router 5 and just do some basic cleanup at this point, because the peering is down. So I'll say router BGP 1, and we'll say no neighbor 5555 and remote AS, whoops, sorry, remote AS 1. All right, so let's go ahead and say write mem here. While that's doing its thing, let's check and make sure traffic's still flowing. So we've actually just done a transition from what is obviously a small full mesh with two IBGP peers. We've inserted a route reflector in here, and as you can see, the route reflector has learned all the information and should be reflecting that information down to router 3 and router 5, because PE1 and PE2, they no longer have a BGP, IBGP peering using the VPN v4 address family. So when I say show IPBGP for let me take that back. So show BGP VPN v4 unicast all for the 6666/32, not 23, 32. We should see that we have a route reflector involved here. You can see from 9999, and that is how it's being reflected down. That's router 9. That is our route reflector. And it just so happens that it turns out that it's also the best. And you can see here, we now have a cluster list, right? We've got the originator ID and the cluster list. And so these are BGP attributes that are now involved in what we're doing because we're doing route reflection, and we need to ensure that we don't cause any loops. All right, so that's the BGP route reflection setup. Let's take a look here at router 1, and router 1 is just cranking away. We never lost any traffic there, and we were able to insert a BGP route reflector into the equation. All right, well, that's our first part in this two-part series. We've got one route reflector in there. We've gotten rid of the full mesh requirement where the clients are peering with the route reflector and the route reflector peers with the clients, but the clients in the cluster do not peer with each other. All right, so in part 2, we're going to come back. We're going to take a look at adding a second route reflector in and talk about some of the nuances that happen when we do that. All right, again, thank you so much for watching. Thank you for putting me over 10,000 subscribers, and I will see you in the next video.